Hi class, it's me, Mr. Morris, and we're going to do Unit 3.9 notes. This is AP Chemistry, Separation of Solutions and Mixtures, Chromatography notes. So first of all, we want to talk about some things we talked about last year. Recall the separation techniques we talked about. Starting out with filtration, this may be one of the most common forms of separation techniques. It's a process of separating an undissolved solid from a liquid by using a porous barrier, most commonly a filter or a strainer. Those are the two main ways that we do filtration, mostly with a filter. Now, keep in mind, this is only going to work with a mixture that you have a undissolved solid. So that's a solid that precipitates. It's a solid that is not soluble in the liquid. So if we look at this diagram we have here, here's our filtration apparatus. This is filtration. And when you see this word residue, filtered solid, that's often a precipitate. If you do a chemical reaction, you get a precipitate, and you want to separate the precipitate out. This is a way that you could do it by filtration. You've got this undissolved, you've got the liquid and the solid in the beaker, and then we start pouring the beaker into the filter. The filter is going to catch the solid, the undissolved part, and that's going to be caught by the filter paper. We have a filter funnel on the outside just to hold the filter paper, and again that residue is your precipitate, and what you get at the bottom after we've filtered, the liquid that comes out is called the filtrate. Okay, so when we talk about a filtrate, you need to know that that means the liquid that passes through the filter paper. Alright, now what about crystallization? Here's a different method that we use in the lab. Crystallization is used to separate dissolved solids from liquids by evaporating the liquid by heating it up. So this works when you've got a solution. It's totally dissolved. We've got an example of it right here. This is crystallization. So we heat up a solution. It looks like it's a liquid, but when you heat it up, you boil all the liquid off, you're left with a solid. That's called crystallization. We're left with solid crystals at the end. Then we get to distillation. You've heard of distilled water. This is how distilled water is made. This is a process of separating two liquids that are mixed together in a solution. They're miscible liquids. They are soluble in one another. We do this by evaporating the liquid with the lower boiling point first. So you heat it up, and the one that evaporates first is going to be the lower boiling point. And then what you'd have left is the one with the higher boiling point. This only works if they have different boiling points. So we've got a distillation apparatus down here. So this is distillation. That's the process of distillation. And one key vocab word that you need to make sure that you know is distillate. Distillate is the liquid that is collected after boiling. So the way this works is we're going to heat up the liquid. We use a heater to heat up the solution of the two liquids, and the one that has the lower boiling point will boil and travel through this tube right here, and it condenses down into the condensate receiver. So the distillate is going to be the one with the lower boiling point. Chromatography. This is what we're going to spend most of today's class talking about. Most of these notes are talking about chromatography. It's a process of separating dissolved solutes based on the difference in interactions with the mobile phase and with the stationary phase. So as you can guess, we're talking about intermolecular forces, the attractions between molecules in determining which phase they're going to be the most attracted to. We'll go through some examples. This is one type of chromatography. There's actually a few different types of chromatography that we're going to talk about, but this is one of the types. It looks like paper chromatography to me. This is our chromatography. So our question that we have down here, which separation method or methods would not be able to separate a liquid solution, and which would work to separate a liquid solution? Or which one wouldn't work to separate a liquid solution? Now, when we say solution, we mean that it appears to be a liquid and it's all dissolved. So it's a homogeneous mixture. Well, the one that won't help us with the homogeneous mixture is is this one right here, filtration. Filtration, you've got to have an insoluble solid. So filtration wouldn't work. Because the liquid solution has no solid be caught by the filter. Now it asks us which methods would be able to separate a liquid solution. So that's the second part. Well, if I wanted to separate a solution that was primarily liquid, I could separate a solid from the liquid using crystallization. I could separate the two liquids by differences of boiling point using distillation, and I could use chromatography to separate components of the solution by differences in their attractions to a mobile and a stationary phase. We'll go through more detail on that, but the other three, all three of the others, could be used to separate a solution that's primarily liquid. So crystallization, distillation, and chromatography can be used to separate a liquid solution. Let's go to the next page. Let's talk a little bit about distillation. Well, distillation is used to separate miscible liquids that have different boiling points. So those are liquids that make a homogeneous mixture when they're mixed together. That's what miscible means, okay? And so distillation can be used for that. It takes advantage of different strength of IMFs between the components. So let's look at an example. Consider the solution of ethanol and water with the molecules above. What are the interactions between ethanol molecules? So if I have an ethanol molecule and another ethanol molecule, what are the interactions they could make? I see electrons, so I know I've got LDF. I also notice this part of the molecule right here, that is a dipole. So it's going to be a polar molecule. It's bent, and this is an OH bond. That tells me that it can form hydrogen bonds with itself. This is a polar molecule, and that's important to recognize. So it can form LDF It has LDF, dipole-dipole attractions, and also hydrogen bonds. What are the interactions between water molecules? Well, once again, we've got these OH bonds, and remember, it's a bent molecule, so it does have a net dipole. So this is also polar, with an OH bond, which makes it able to form hydrogen bonds. So it also forms LDF, dipole-dipole, and hydrogen bonds. What are the interactions between ethanol and water molecules? Well, see, this oxygen from one of them could be attracted to the hydrogen in the other, right? And this hydrogen could be attracted to the oxygen in the other one. And in either case, that's a very strong attraction formed by these OH, these very polar OH bonds. So because of those OH bonds, they could actually form all of these types of attractions with each other. So we've got LDF, dipole, dipole, and hydrogen bonds. So let's look at this. The boiling point of ethanol is 78 degrees Celsius, and the boiling point of water is 100 degrees Celsius. So water has a higher boiling point. What can be concluded from the boiling point data for the two substances? Well, we can determine that the IMFs between water molecules are stronger than the IMFs between ethanol molecules. Because the ethanol molecules are evaporating first, we know that they have weaker intermolecular forces between them than water does, than water molecules do between them. All right, when a solution of ethanol in water is heated, which substance will boil first? And explain that by discussing the strength of the intermolecular interactions between and the components of the mixture. So if we look at the boiling points, we can already deduce that since ethanol has the lower boiling point, ethanol will be the one that boils first. But it asks us to explain it in terms of intermolecular forces. Let's start with our claim, though. Ethanol will boil first. By the way, that means it will be our distillate. It will boil first because the IMFs between ethanol and ethanol molecules is weaker than IMF between ethanol and water, and also weaker than the IMF between water molecules.